Hi students, today I am going to discuss about equivalence class. So here students, let's see what is the definition of equivalence class. So here definition. Let RBN equivalence relation in a set A, and let small a belongs to the set A, then the set of all those elements of A which are related to A is called equivalence class. It's called equivalence class, determined by A, and it is denoted by square bracket A. Okay students, that is equivalence class of A equal to, it is the set B belongs to A such that A related to B, AB belongs to R. Okay students, so here clearly for equivalence class R should be an equivalence relations. Okay students, for finding equivalence class of element of set, so here relation should be an equivalence relation. Okay students, so here the definition of equivalence class is, let R be an equivalence relation in a set A, and let A be the element belongs to set A, then the set of all those elements, that means the set of all those elements of A which are related to A is called equivalence class, determined by A, and it is denoted by square bracket A. Now we can write it, square bracket A is equal to B belongs to A such that AB belongs to R. Okay students, now take an example for clearing the concept equivalence class. So let's take an example students. Let we have given the set A is equal to 1, 2, 3, 4 and 5, and equivalence relation R. Here R is equivalence relation, okay, equal to 1 1 1 2 2 2 3 3 4 4 5 5 5 1 1 5 4 3 3 4 3 2 2 3 and 4 2 2 4. Okay, this is the element of R. So here students, clearly this is the set A and R with the equivalence relation. So here we will find the equivalence class of each element of A. So here, let for all A belongs to capital A, the equivalence class of 1 equal to, here students, the equivalence of by the definition of equivalence class, the equivalence class of 1 will be here. This is the set of the elements those are belongs to A which is related to 1. So here will be 1 is related to 1 also. So 1 will be the equivalence class of 1 here, and 1 is related to 5 also, 5 is related to 1 also. So here 5 is also equivalent class of 1. Okay students, now equivalence class of 2 will be here. Here 2 is related to 2, so here will be 2, and 2 is related to 3 also, 3 is related to 2 also, so here will be 3, and 2 is related to 4 also, and 4 is related to 2, so here will be 4. Now the equivalence class of 2 is equal to 2, 3 and 4. Okay, here equivalence class of 3 will be equal to, here 3 is related to 3, so here will be 3, 3 is related to 4, so here will be 4 also, and 3 is related to 2 also, so here 2 will be present also. So here the equivalence class of 3 is equal to the set of the element 3, 4 and 2. Okay, now the equivalence class of 4 will be, here 4 is related to 4, so here will be 4, and 4 is related to 3 also, so here will be 3, 4 is related to 2 also, so here will be 2. So here the equivalence class of 4 will be the set of 4, 3 and 2. Okay, now equivalence class of 5 will be here. Clearly in R 5 is related to 5, so here will be 5, 5 is related to 1, so here will be 1. Okay, now okay, enough. So here these are the equivalence class of 1, 2, 3, 4 and 5. Here students, clearly the equivalence class 1 and the equivalence class 5 is equal here. So equivalence class 1 equal to equivalence class 5, and equivalence class 2, 3 and 4 is also equal here. So here will be the equivalence class of 2 equal to the equivalence class of 3 is equal to the equivalence class of 4. Okay students, now here clearly the union of equivalence class 1 and equivalence class of 2 or 3 or 4 is equal to A. So here students, equivalence class of 1 union the equivalence class of 2 is equal to A, and the equivalence class 1 and the equivalence intersection of equivalence class 2. Here 1 union 2 is equal to A, and here will be the equivalence class 1 and equivalence intersection of equivalence class 2 equal to here will be 5 students. So clearly the two equivalence classes are either disjoint or identical. Okay students, so from by the help of this result we can write it here. Therefore two equivalence classes are either disjoint or identical. Okay students, so here the equivalence class 1 equal to equivalence class 5, and here equivalence class 1 intersection equivalence class 2 is equal to 5. So here by the help of this result we can say that the two equivalence classes are either disjoint or identical. Okay students, so here students we have discussed about equivalence class, and we understood this by the help of an example how to find equivalence class in a relation. Okay, thank you so much.